It all begins with a visit from insulin. He knocks on the door and expects magic to happen. That is, the cell should lay out a red carpet and let insulin inside. From the inside, he can do his job. When insulin resistance occurs, this does not happen. Actually, nothing happens. This causes trouble on the inside, impacting fuel supplies, and trouble on the outside. The nutrients have nowhere to go and start accumulating. Then the sugars gum up the works. So let's review what is supposed to happen. Insulin 101. Well, the pancreas distributes insulin parcels in response to glucose. Now, the parcels don't go directly from the pancreas to the muscle and fat tissues. They have to pass through the liver. Approximately half of the insulin secreted by the pancreas makes it out of the liver. And from here, insulin goes about his business, which is to put the groceries away after dinner. Specifically, the sugar is distributed to muscle and fat tissues. Now, most cells have an insulin receptor or two. So there are lots of places insulin can visit. And as far as insulin is concerned, if he sees an insulin receptor, it's a welcome mat. He knocks on the door expecting some kind of response. Now, what he gets up to once he makes it inside depends on the cell he is visiting. The point: insulin is looking for insulin receptors, not cells. And it turns out that it is possible for insulin receptors to be circulating without cells. This is what a group of Mexican researchers recently discovered. Join us for this episode of Better Body Chemistry TV as we find out what floating doors, that is, soluble insulin receptors, have to do with insulin resistance. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heifer lumps, and other health horribles through better body chemistry. Remember, small things can make a big difference to your health. Now, the Mexican team of scientists started by looking for unattached insulin receptors in rats with metabolic problems. To do this, the team looked at the size of the insulin molecules floating in the serum using a technique known as Western blotting. Approximately 40% of the insulin was bigger than predicted, suggesting the insulin was attached to something. Using antibodies that can pick up the insulin receptor, the team confirmed the something the insulin was attached to was an insulin receptor. Now, they did the same investigation in humans, and it happens in humans too. Just as in the case of rats, the insulin that is circulating is not always free. It's attached to floating insulin receptors. Now, this happens in both healthy and diabetic folks, but it is a bigger issue in the metabolically broken. These people have a lot more insulin floating in the blood because they have hyperinsulinemia, and a higher percentage of what is floating is bound to soluble insulin receptors. So, does it matter? Probably. If insulin is knocking on floating doors instead of real doors, the response to insulin is going to be impeded. Insulin resistance, anyone? So, why are the insulin receptors being jettisoned? Curious. The team exposed liver cells to different concentrations of insulin in a petri dish and watched what happened. Prolonged exposure to continuously high levels of insulin prompted the liver cells to jettison their insulin receptors. The amount of shedding was proportional to the amount of insulin. That is, the more insulin caused more shedding. It's a matter of survival. You see, insulin causes both blood pressure and sugar levels to drop precipitously. The liver cells are among the first cells to encounter insulin. Being mindful of the potential danger the elevated insulin levels pose sparks a defensive process that causes the insulin receptors to be jettisoned off. The more insulin, the more receptor disposal. When insulin binds to these floating insulin receptors, the effective concentration of insulin is instantly lowered to safe levels. But the problem is, with a high percentage of insulin tied up, literally, the actual amount of insulin being delivered to muscle cells and fat cells is significantly diminished. They're not deliberately ignoring insulin's cries. Insulin is not there. So the glucose gates are not translocated, and insulin is not able to put the glucose away timelessly. This results in high sugar levels, which create a bit of a panic, and more insulin is dispatched. Once more, there is a problem with delivery. Aish. This research suggests the drama begins with too much insulin, not insulin resistance. So, to improve your levels of insulin resistance, work at bringing down your insulin levels through diet and lifestyle. For some suggestions on how to do this, download our free report. You can find the link in the description and begin the journey today to better body chemistry and better health. Interested in discovering more ways to create better body chemistry, or need a little help getting your body chemistry on track? Visit our website at www.betterbodychemistry.com. Browse our library or enroll in one of our courses or programs. The advice is simple to follow and based on real science, not hype. Know someone who is insulin resistant. Share this video with them so they understand Insulin is the reason they're insulin resistant. So to improve insulin sensitivity, insulin must be reined in. And if you enjoyed the video, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.